Good evening, everyone, or good afternoon, good morning, wherever anyone is. My name is Eoin O'Donoghue, and with Claudia Röck today, we want to just go into a bit of the work that we have been investigating on the area of archiving the dynamic web, and specifically servers and browsers. We've been working as part of a research project for the Digital Heritage Network here in the Netherlands. The main focus of that is to lower the threshold for people or institutions getting into the area of software preservation, and we include in that web preservation as well. To this date, most of the work that we have been carrying out has been focused on the software side of things, but we're delving a bit more into the dynamic website side of things now as well. And Claudia has actually done a lot more research into the area of preserving browsers and emulating browsers. So just a general overview on the objectives of the project we've been working on so far. We wanted to investigate the possibilities for an infrastructure for access to obsolete software through emulation. This was focusing on the emulation as a service framework. And we've just come to a point where we finished our research of that, and we have a report coming out this month. It's going to be published on the NDE website. Furthermore, we're looking to create knowledge development within the Netherlands, and specifically within the group of our project partners that we're working with. So this is anything from metadata for software collections, kind of best practices for how to go about collecting and preserving both software and web content. We've also been taking stock of existing software collections in the Netherlands. IDFA was looking after that, and that was kind of a series of interviews with different institutions and what sort of materials they currently have in their collections. And then we also want to put together an inventory of barriers for the use of legacy software, and barriers for institutions that want to start collecting software and web content. So just a quick look at all the project partners that we've been working with. They include the Regional Archive in Alkmaar here in the Netherlands. We worked with them for some of their video games collections. We have Het Nieuw Institute, which collects digital architecture plans and projects. We worked with some of their architectural software and that they have files for in our emulation research. Lima, which Claudia focused on quite a lot, which researches and archives digital artwork. And there's a lot of examples of browser-based artwork in there. And then ourselves, Sound and Vision and Building Cloud. We have video games in our collection, but also we have more traditional web-based archives, and we want to make more of a splash in the area of dynamic web. And then the eScience Centre here in the Netherlands as well, which produces and archives software for research. So as I said, Sound and Vision already uses web crawling as a strategy for preservation, as described here in the 4 steps for web archiving. The first one being selection, and this is as determined by the archivist or the curator. There's so much out there on the web that you kind of need to narrow the fields and have selection criteria for what you want to collect. The harvest process then, where the crawler actually works through the web pages and makes copies of all the data. And preservation, in this context, wrapping the data in a familiar WARC file with the associated metadata for preservation, and then providing access to an end user, which could be in the format of many different playback tools, one being the Wayback Machine. So for this kind of scenario, it's more ideal for creating snapshots of static websites over time, but it doesn't really handle the dynamic web terribly well. So as I said, we're now looking forward to expanding our research into that area. Much of today's web is dynamic, and it offers users personalized experiences based on the choices and the selections that they make. So this has been referred to as deferred representations, whereby client-side technologies such as JavaScript are used to change the client's state of a representation after it is initially loaded. This can be troublesome for traditional web crawlers, which only really scrape the surface that the browser can see, and it may not capture some of the more complex transactions that happen between the client side and the server side. So because of this, there's the possibility of losing or misrepresenting some of the dynamic experience. So I personally have started looking at some tools that we hope can help us in this area. William already mentioned Conifer, which we have been looking at already. It used to be Web Recorder. Conifer is a user-driven platform that allows the capture of high-fidelity interactive experiences while the user browses through a website. It's supposedly has higher success rate when capturing complex scripting, such as embedded video and 3D graphics. And in some of the tests that I've used, it's been quite favorable. I've seen some nice results from that. And then ReproZip is another tool we're also looking into. It can be used to track and trace the processes and data files, libraries and environment variables of dynamic websites, and pack them into a self-contained bundle. And from that then, this can be reproduced, allowing the original environment to be interacted with on either a different system or a different browser. So we're working on 2 specific use cases at the moment from a company called Submarine. It's a production company in the Netherlands here that produces feature films, documentaries, animation, and transmedia stories. The 2 that we're looking at are The Last Hijack, which is an interactive documentary telling the story of piracy in Somalia. It features interviews, animation, data visualizations, which all become available at different points of an interactive timeline as the user navigates through. The second use case is Collapses, which again is a transmedia storytelling experience. This one deals with issues surrounding global energy politics, and it contains documentary footage, some mini games for the user to interact with as well, and movie clips. Both of these examples were developed in PHP and feature interactive elements rendered in JavaScript and Flash, RIP. And they both rely on Google Maps as an external resource to render some of the features that users can engage with. So our initial appraisal of these 2 projects, we received 2 large file transfers from Submarine for both these use cases. First step was just to review the server files associated with each project. As you can imagine, there was hundreds of files with multiple formats, and this can be difficult for a non-web developer to get a real understanding or a feeling from. I have some experience in that area myself, but not from a production level, and certainly not with projects of this scale. But from that initial kind of review of the projects, we were able to attempt to set up a local deployment of each of the websites using the PHP built-in server. This was executed using the command line, so there was knowledge of that side of things as well. And once we got them up and running, we tried to do a side-by-side comparison of the local version of the website compared to the live version of the website. Now, the last hijack was the one that worked better than the other. The majority of the processes in the last hijack worked quite well on the local version, but any of the calls to the Google Maps in the local version, it wasn't quite linking up correctly. So you can see in the image up above there, both taken on the left is from the local instance, the right is from the live instance. So the overlay just wasn't working quite as it should have, and there was no interaction available for the Google Map, which should have allowed the user to zoom in and move around to see the information as it's displayed. So yeah, it led to kind of mixed up overlays, and we couldn't get the full experience of data visualization elements. For Collapsis then, there was troubles from the get-go with Collapsis. The live version seems to be experiencing issues accessing files from their server. So if you go onto the live version of Collapsis, not all the content is displaying. We kind of went through the, sorry, there's a cat running around my house like crazy here. Yeah, we went through the Google Chrome developer tools just to see what the specific files were that were causing issues, and we were able to match them up to the files that we had received from Submarine in the file structure. But still in the local version, there was some sort of missing link there that we couldn't quite get up and running. So that's something that we're hoping some of the next steps we want to take can help us out with. And we've identified these as some of the key needs for what we want to do next and how we can move forward. So first and foremost, our only real collaboration with Submarine at the moment has been to receive the files, and we're very grateful for them to provide them. But we realize that it's essential to collaborate with them further. So the earlier the better you can get into this this communication. Yeah, it just makes things a lot easier. But you also have to be aware of what both sides can bring to the table. We're thinking at the moment that some form of in-depth interview with the creators will be very beneficial, understanding the creation process, and possibly even getting some technical support in setting up these local instances and just being able to carry out our tests as fully as possible. So yeah, and I mean, that will help us kind of put together a list of the essential components that we need to preserve to make these, yeah, just to make these accessible in the future. So from the list of dependencies, yeah, we can create a clearer picture of what the environment will look like overall. And this will allow decisions to be made on the preservation needs of individual dependencies that are highlighted as risk factors going forward. So, for example, Flash is just a perfect example there. And then the next step, we want to do some further evaluation of the tools, including Conifer, which seems to work quite well, but it's just a bit taxing going through, making sure that you can go through each process and capture it, and knowing that you have everything available on the website recorded. And then ReproZip, which might be able to capture a clearer picture of the environment as a whole, and wrap it up in a nice bundle or image. But there is certainly a technical barrier there that we are working on. And I think once we get the local instances of both use cases up and running, we will be able to plow ahead with that a bit more and hopefully get some good results. So I'll hand over to Claudia now to talk about the web browser characterization.
Claudia, I think you are muted. Yeah, indeed. Can you hear me now?
Yes.
Yeah, Owen told you about his research about server-side preservation of dynamic websites, and I will now talk about a detail, which, well, not server-side, but client-side preservation. And I will talk about the influence that different web browsers have on the presentation of websites and how web browsers can be characterized, used, and preserved. The topic of this research was suggested by Lima, an institution in Amsterdam that is distributing, preserving, and researching media art. Lima set up a project called ArtHost, which means that Lima hosts and preserves web-based artworks for artists. So Lima also contributed the case studies for this research. I also want to mention that Rhizome, the institution in New York that created the Conifer web archiving tool, holds a lot of knowledge about web browsers. However, they have not published a lot about their experiences and research about web browsers. In general, I found very little literature about the significant properties of web browsers. So we wrote a report about that topic, and I'm presenting you now the results. Now, the questions I would like to answer, next slide, please. Yeah, thanks. The questions I would like to answer in this presentation are, what are the differences between browsers regarding the presentation of websites? How do you choose a browser for a website? Are browsers and their components still available? And what can browser emulation be useful for? These are actually questions that were also asked by Lima. That's why we try to answer them. Next slide. So I'm starting with examples where websites are presented differently in different web browsers. In this slide, you can see the artwork div property created by Yodi in 2014. It is a JavaScript animation playing with the two background images of Windows on Mac OS. Now you don't see the animation, but okay. However, this animation is not played back in the same way in every web browser. In Safari 1010 on the left, the two images rotate around each other on a diagonal axis. On the right-hand side, Firefox 66 rotates the two images around a vertical and a horizontal axis. It looks quite different. And both web browsers are versions from 2016, so from the same time about. After talking with the artists, they confirmed that they preferred the Firefox 66 presentation of the website. So next slide. Yeah. This is an example where a newer website is represented in an old web browser, which is rather an unusual case. This is Yodi's overview page presenting their web-based projects. As you can see, the Chrome version from 2017 cannot represent the icons properly. In contrast, the current Chrome version renders the icons well. The difference between the browser versions is just 3 years. Next slide. What is more common is the presentation of an old website in a new browser. The website you can see here is part of a web-based artwork called Trace Noiser by the artists collective LAN and dates from 2003. This is also like a performative work. I don't know whether you can see it, but the fonts used by the browsers are different and the positioning of the images differs as well. On the left, you can see the website presented through Mozilla 1.3 from 2003, and on the right, through a current Firefox browser. Next slide. Tebat.net, in particular, the animation grammars, is a website designed by Trevor Batten in 2004. The animations are made in Java. On the left, you can see the start screen of the animation grammars in a current Firefox browser. If you click on it, you will get the message that you need a Java-enabled browser to run the animation. Web browsers are not able to interpret Java. They need a plugin for that, but Java plugins are obsolete since several years. Hence, it is only possible to view this website with an old browser version with a Java plugin installed. Next slide. So from these practical examples, but also from more theoretical considerations, one can deduct a list of significant properties of web browsers. Well, this list is not complete, it's a suggestion. So the positioning of websites elements, the scaling of websites elements within the browser window, the fonts used, the ability to render web animations, the look, sounds, and movements of web animations, as for instance, the execution of the JavaScript commands in the div property website, browser-specific add-ons or toolbars, browser-specific non-standard HTML commands. For instance, the blink element supported by Netscape Navigator was not supported by many other browsers. So the blinking writing was only visible in this browser. Then there's also bugs in the browser engines, and certain web designers and artists are using these bugs. And then the colors can also differ. So old browsers are not color managed and cannot interpret color profiles correctly. Next slide. So where do these differences come from? Browsers are complex pieces of software that went through a fast development since they were invented. Under the hood, they consist of a browser engine, a JavaScript engine, and interfaces for plugins and hardware. They are also part of a browser ecosystem consisting of the operating system, plugins, and add-ons. As a result of their fast development and progress in web standardization, there are hundreds of browser versions, of plugin versions, and add-on versions. Next slide. So it is good to know that these browser plugin and add-on versions are all hosted by company archives. There is a huge risk that you will not be able to download the old versions you wish. Hence, it is important that when you're acquiring a website or a web archive, you also capture and preserve the web browser environment, because otherwise it will disappear very quickly. Next slide. But how do you choose a web browser for a website if there are hundreds of versions? I showed you earlier how you can characterize browsers according to their significant properties. However, there is no overview of significant properties of web browsers that you could consult. In addition, due to the limited availability of certain browsers or add-ons, not every browser environment can be assembled. Hence, a good way to go is to ask the creator or user communities of this website which browser to use. And another obvious way is to choose the software versions according to the year the website was produced or last updated. An atlas or inventory of browser properties fed by users would help with that task. There is something like that for AV artifacts. It's called the AV Artifact Atlas, and it would actually be very helpful if something like that existed for web browsers. Next.
I'm sorry to interrupt, but we need to wrap up.
Oh yeah, okay.
Quickly. Thank you.
I will go. I'm at the last slide actually. Yeah. So what can browser emulation contribute? It can render websites that need plugins or specific HTML features that only obsolete browser versions can provide. And it can be permanently linked to a website through a cloud service so that users don't have to install the emulator themselves. But it cannot fix server-side problems of the website or missing resources. Yeah, that's all.
Thank you so much, both to Claudia and Eoin, for really interesting presentation into kind of the practicalities and the nitty-gritty details of preserving all of these interactive works. Since we're running out of time, I'm just gonna pose one quick question that we have in the chat from Patricia. Can you talk a bit about the difference between ReproZip and Docker?
Well, from what I'm aware at this point, you need both a containerization platform and ReproZip. So you can bundle up your experiment or your website as a ReproZip file, and then you will actually use Docker or Vagrant or something similar to deploy it then as a new instance. So that's one of the complications that we're still trying to figure out. We were able to trace experiments and trace website resources and create the ReproZip file. But when it comes to redeploying it and recreating it, yeah, there's just been some additional complications with things like Docker or whatever containerization platform you're using. So that's next steps, literally trying to get that that sorted.